Hello there. Unfortunately, we're going to be watching me doing a voiceover of myself because I had apparently recorded the whole video for Stacks without actually realizing that the audio was not recording whatsoever. So we get to watch old me do some of the coding here. Now, with regards to stacks, before talking about stacks at all, we need to talk about the components of a stack, which are nodes. So anytime that you have elements of data that are going to interact with each other in a way that's more complicated than just an array where everything is nice and sequential and lined up, usually you're going to have this concept of a node. It's going to be you can think of as a little blob in memory, and it has two important components. The first component is it has data, and the second component is it has a pointer to another node, usually. Sometimes it's a pointer to nothing, but the reason that we use these kinds of structures is because it might be the case that we want to make data in a specific order, and everything that we're going to be coding here is going to be in the intent to later order data in a certain way. So we make a structure, it's going to have data inside of it, and it's going to have a pointer to another node. So to make it have a pointer to another node, we write node star. We'll call the pointer next. And just to show what this actually looks like, I'm past me is coding a couple of nodes, N1, N2, N3 are all the names of different nodes, and then we'll be able to see what this looks like in memory. Is there anything I want to add at this point? Not particularly. What am I doing now? Oh yeah, so once I make my three nodes, I need to give them values. So I can use n1.data to assign n1 the value of 7, n2 the value of 8, and 3 the value of 9. This works just like we've seen already when talking about structures and classes. You can use the name of the object dot the variable name that you want to change, and this structure lets you change it. Now, if I want to use a pointer to point to another node, I need to say n1.next, which is the name of the pointer belonging to n1, and I want to give it the address of n2, so it's going to point to another node. Now, I think what I coded there might not work right away, so I probably have to end up fixing it. That's okay. I'll presumably catch it in a moment here. What are we working on now? I guess I'm pondering. I think the next part of the exercise was print everything out, and I was trying to figure out how I was going to print it all out. Now, in this exercise, we have three nodes. So if you really wanted, you could just write a for loop that runs 3 times, and it prints out the value of a node. And then in each loop, after printing out a single node, it moves on to the next one. With an array, this is really easy because we can use a for loop with an index and use the index to reference each element of the array. Makes it really convenient. With a node, things are a little trickier because you don't know how many nodes you have, for example. Now, in this case, we can cheat. We can say, there's 3 of them, so duh. But in the case that you don't know how many nodes you have, how would you do this? Well, one approach you can take is you can use the next variable and keep moving from one node to another one along the path, and I think I'm kind of figuring out how to do this in the video at the moment. But importantly, in order to track which is the node I'm currently working on, the same way that my array example with a for loop would have an index that tracks the current element, I need to use a pointer that's going to point to a given node. And I think, again, what I've done right here isn't quite going to work for a variety of reasons. But I think I in the video find out quickly enough why that is. So some of the mistakes I made here, for instance, I need to put the addresses there for some of the nodes. I need to indicate that n is going to be a pointer to a node. I definitely need to make sure my counter increments. So fixing here, it looks like I might be running this first to see what happens. But what we have here isn't quite right yet. We still have some changes that need to be made. So what I want to do in this exercise is I want to print out the data from each node. So I'm going to print out, data from node 1, node 2, node 3 is going to be, and I need to get the data, which is n.next. Now, or n.data. Now to get from one node to another, and now I have all these errors I have to fix, I want to reassign. If I have n as a pointer, I want to point it to the next thing. The thing in the video here, what I'm fixing right now is that n1.next is a pointer, so it needs to get an address of a node, which is why I need to add the ampersands in here. And in my loop here, where I'm about to fix this, I need to set n to be a pointer because my goal here is to have my 3 nodes all lined up next to each other nicely, and I want to have a pointer so I can point at each one. I can say print this one, then print this one, then print this one. And in my, I also need to change, instead of n dot data or n dot next, you need to use the arrow because n is a pointer. Okay, so now when I run it, everything works nice and clean, although I've cheated here because I've just said, do this 3 times. In fact, I'm actually not sure why this worked in the first place because I forgot to increment the counter. So I don't even know how it figured out to stop. Something weird must have happened there, but counter plus plus should take care of that. But this only works because I know there's 3 of them. If I don't know that, then things get a little trickier. And I think when we work on the stack, we will probably be able to find a cleaner way to do this, but for now, we also want to see what this looks like in Python Tutor. And this is, I think, the more useful way to work with nodes and stacks and so on, because you can see the connections between the different nodes that are here. Okay, I got my nodes, I got my data, I set up my pointers, so n1 points to n2, n2 points to n3. You can think of it as like a little chain, like you got 3 golf balls that are all threaded together, and one follows the next one. And I have a little counter that's going to go 3 times. I have a pointer so I can point to each one of my nodes. And 3 times I can print out the data from whatever node number is equal to the data that's there. Then I can move my pointer to the next one that's there. And then it will show everything. So now I think it's going to run and it should show all the steps. So over here we can see in the stack, we have our 3 nodes. They're objects that contain data and a pointer being called next. When we set everything up, the pointers all have null inside of them, meaning they don't point to anything. And the data starts out as 0, but we're going to change it to 7, 8, 9. And then we're going to make n1 point to n2, n2 point to n3. So now you can see we have the little structure here that we're trying to do. A data structure, if you will. Now, n is pointing to n1 because I want to go through each of my nodes and print out the data one at a time. So I print out the first one at 7. Then I need to move my pointer n to the next one. So you can see that the arrow from n and the arrow from next at the top are both pointing to the same spot. And now these other 2 arrows are both pointing to the same spot because I'm changing the value of n to be what the value is of all these next attributes for all my different nodes. Okay, now I think I might be realizing how I can do this better, which is instead of counting it 3 times, why don't I keep going until my n is null? Because one of the next values was null when we were done. So if our n, our pointer to a node, starts out at n1, then it points to n2, then it points to n3, and then it points to null, nothing, I know I'm done after that point. I don't have to count 3 times, because who cares? I can just keep going until I reach the end. And this is the ideal way that you want to go through different nodes. So look, I go through the first, second, and hooray, we're all good. So this is the way you should try to iterate through nodes. Doing it by counting how many nodes are there is great when you know exactly how many there are, but you don't always know that. And hooray, it all worked nice and cleanly. Yeah. Anything else to add here? No, I feel like this is the end of the exercise. We're probably going to move on to the next one momentarily. But it's really good to make sure that you practice this. I think if you've watched this video but you haven't tried coding it yet, you're really doing yourself a disservice. Okay, time for a stack. So let me pause this video just so I can talk about a stack for a second. Past me, you're going too fast. Let me backtrack a moment. Let's talk about a stack. So what is a stack? I think the way that I learned about them was thinking about a deck of cards. So if you think about a deck of cards, each card is piled one on top of the other one. And so if I were to draw from the deck, which we call popping, we'll see that in the next exercise, you take the top card off. And if I was to add a card to the deck, meaning slap one on top of it, we call this push, the top card is always going to be the one that I interact with. If I'm adding stuff, I'm adding to the top of the stack. If I'm taking stuff away, I'm taking from the top of the stack. And the objects of the stack are nodes. So when we build our stack class, which is going to represent this idea of sort of a deck of nodes, we are going to use nodes to represent each little piece that's in there, and we need to make sure that the idea of them being piled on top of each other is represented by the pointer system that we've set up. So by having one node point to the one below it, we're saying it's on top of the other one. The word top is going to get used about 1,000,000 times in this video, so apologies for that. Okay, let's move myself forward so that I'm not falling behind. Okay, so we need to make a stack class. So the stack class is going to have a bunch of nodes in it. It's going to have a bunch of methods that make the nodes do different things. But it's important that we keep our node structure because we're going to use that as part of our stack. Fortunately, our stack only has one variable, which is really nice. It's a private variable called top. And top here is a node pointer. It's going to point to whatever the top of the stack is. We want to always know what's on top because that's the thing we interact with the most. So here I am adding the documentation, always good to add. So I'm going to need private variable top, a constructor, an accessor, and a push. So the first is easy. A private variable top is going to be a node pointer, so node star top. And when we make our constructor, we're going to initialize this to be null because the first time you initialize a stack, it's empty. There are no nodes in it. So to represent that, we're going to use null, just like we saw in the last exercise. Now, our constructor is just called stack. Our accessor for top is a get function, so probably get top makes perfect sense. And if it's going to give us the node back, or at least a pointer to that node, then we're going to need to give it that type. I guess you could make this a node type or a node star. It's kind of up to whether you care to have a pointer to it or if you just want to have the top itself. So here I would just write return top. And so since this is a one line function, you often just can write it inside of the class. You don't have to go declare it elsewhere because that's lots of extra code you don't have to write. Much faster just write return top here. But if I wanted to get the node itself, I could write return star top, and that would give me the actual object as opposed to a pointer to the object. It's up to you which of these you'd rather have. Now, I also need to push, lowercase p. Thank you. So push is going to take a, you could either take a node or you could take the data. It depends once again on how you want to implement your stack. In this case, I think I go with a number. But you could do it the other way where you could take a node and push the node in. In either case, do I change it? I think I'm checking to see if there was a specification, which is always a good thing to do, see if there's instructions for it. But I think, what did I go with? I went with pushing a node, which makes more sense. You should build the node first and then add it to your stack, which will then update its pointers and everything. It's better than, I think, just trying to push in a number and then the function has to make the node. It gets a little messy that way. So, okay, I have, to make these things work, and then I'm going to use my main function to call these and iterate through them. Okay, so let's let's make push work. I think I forgot to make the constructor, so I'll probably have to go back and do that. But push is a function that's going to take a few steps, so it's always good to make sure I know what those steps are before I start coding it. I want to figure out, what are the actual things that I'm doing. Because this is a function where if you mess up something, if you get the orders wrong, then things kind of go messy. Now, the first thing I need to think about is what if the stack is empty? If the stack is empty, this function is actually really simple. I just need to replace the top with the new node. Or at least the top should point to the new node, the one that I'm trying to add. And that's it, right? If there's nothing else that I have to do, then I'm done. The only time that push gets complicated is when I have a stack already. Then I have to reorganize things. Fortunately, I only have to care really about the top of the stack. Everything underneath the top is already in nice order and it's fine and done. So not really a problem. So I think here I'm pondering, what are the things that I have to do to build my stack? And there's effectively 3 steps, which I think I'm going to write out shortly. So it looks like here I go. The first of these steps is to get the top node. I need to hold on to it because the top is going to change. If I'm adding something, then whatever was on top is no longer going to be there. And what I want to do is make my node that I'm adding on top refer to the thing below it, so I continue that structure. And then once I've done that, I need to make sure that the actual top of my stack is the one I just put in. So I do these 3 things, and once I've done them, then I've completed my function. So one thing at a time, I need to get the top node of my stack. There's a couple ways you can do this. You can get a pointer to it, is not a bad idea. You could make a copy. There's a few different ways, but importantly, I want to make sure that I can hold on to that because if I change what the top is first, then things can get messy. Now, I should also point out there are different ways to implement this function. This is just one example. There are probably faster or cleaner ways as well, but I just want to make sure I have all the right steps. So I get the top node, I call it old top. I make our new one that we're putting onto our stack point to the one below it by making the new node's next pointer point to what was on top. And then I update, now the top of the stack is the one that I just put in. Hooray, that's it. Nothing else to it. My main function, I need to make a stack, push some nodes, and then iterate through them. And I can iterate through them using the same technique that I did in the first exercise, but I guess I decided to change the parameters of the question because I felt like not iterating, and I think it's better to see what this looks like in Python Tutor anyway. Python Tutor has the unfortunate problem, though, of when you line up all of the variables, all the arrows kind of overlap with each other, so you do have to kind of mouse over them so you can see which arrow is which. It gets kind of messy otherwise. But we'll make do, I think, with that. So I'm going to make some nodes. 3 nodes, N1, N2, N3. We're going to give them values, 7, 8, and 9, just so we can tell them apart. Okay. We're going to make N1 point to N2, N2 point to, or no, actually, no, we're not going to set up the pointers. We're going to push them. We're going to make the stack do this pointer nonsense. We don't want to have to manually do it. So we're going to push N1, N2, N3. So N1 goes on top, then N2 goes on top of that, and N3 goes on top of that. Unfortunately, the order that they appear in Python Tutor is not quite going to match that, which is unfortunate. Oh, and I think I forgot to do my constructor, right? Oh no, I forgot to mention that push belongs to the stack class, so I need to do stack : : push. There's actually a few mistakes I made here, and I guess I can go through them as I correct them. So I need to use stack : : to indicate this part of the stack class. I also didn't make the constructor, so I need to do that. So here's my constructor, stack : : stack, and all it does is set the top to be null, because my stack should initially be empty. Nothing else needs to happen there. So that's done. Now I think this should work. Unfortunately, it's going to be a little messy. So, okay, we got our stack. Now, here again, our stack is just going to be a pointer to the top of it. When we look at the actual stack object, it doesn't include inside itself all the nodes. It just says, okay, our nodes are all ordered up. Here's the top of them. And then each one points to the one below it, just like they're piled on top of each other. Now, the other thing I didn't like about this is that my new node is like an actual new node. It's not a pointer, which is kind of annoying. Because when I want to push something, I don't want to make a copy of the thing I'm pushing. I want to actually just refer to that thing. So I think I end up pausing here at some point. But the steps that we go through are important here. Am I gonna edit this? Yeah, I think I'm gonna edit it. Yeah, we're gonna fix this up. This should not be creating new nodes. And also, if the stack is empty, we don't want to do a bunch of other stuff where it's actually going to break. So I forgot to put in the else. So without doing the else, what ends up happening is some unfortunate business. Again, you can rewrite this push function in a number of different ways. So the way that I did it doesn't necessarily have to be the best way. There are definitely a number of implementations of stack out there that have different versions. I think this is fine, but there are probably better ways, I would say. Maybe at some point I can write one. I think in class I did it slightly nicer, but at the point at which I'm recording the voiceover, that was the other time. Now, okay, those ampersands should not go there. That's a mistake. Those ampersands should go up at the top here, because I want to pass these nodes by reference. I want to pass pointers to them. And ampersand has to go both there and in the declaration of the push. So now that I have executed this, it will be passing pointers to the nodes that I want to add to my stack. So my stack originally is nothing. It's just pointer to null. My 3 nodes don't point to anything and just are going to get numbers 7, 8, and 9. And then when I push N1, my stack will just be a pointer to N1, which is the bottom and the top of my stack. There's nothing else that's there. When I push N2, N2 goes on top of it. And so now I have a stack of 2 things. And when I push N3, that goes on top of that. Unfortunately, the picture here is actually kind of inverted because I have N1 is above the others in like the visualization, which is not quite what I would like. So I think I will go and at some point modify these the order of these nodes just to make it a little cleaner. Also, the arrows here are like kind of unfortunate in that they overlap with each other a lot. It becomes really messy to see everything. So this is definitely a case where you want to not just watch the video for this, but I think you want to try and to do the coding and walking step by step so you can see which arrow changes in each step of the code. I think if you just watch this video where these arrows are really overlapping each other somewhat confusingly, it's kind of hard to follow what's going on, especially when the arrows are disappearing. So you really should try coding this and running it so you can see on Python Tutor how all these arrows move around one step at a time. I think when I rearrange this, it's still a little bit messy. It's not as bad, but it's still like a little confusing, I think, which is not ideal. And that's just an unfortunate case of how Python Tutor manages things. But if we look at what's going on right here, the top of my stack is N2, and then after N2 is N1 is below it. So here's N2 top, N1 below that, and that's what my stack looks like. But unfortunately, all the arrows get like all over the place. And now once I added N3, I got N3 on top, N2 below it, and N1 underneath that. So if you follow the arrows, S points to N3, the top, N3 points to N2 underneath it, and N2 points to N1 underneath that. Which is what you want. It means our push is working. Just picture is kind of ugly. Do I reorient them now? Is it time? Yeah, so we're gonna push N3 to the top / bottom of our stack, then push N2 on top of that, then push N1 on top of that, and then when we run through everything, the arrows should have less overlap. In fact, it should have almost no overlap. There will be a little bit of pointers crossing when I'm pushing things because I need to have the new node point to the right thing. But here, now I've pushed N3. My stack is just N3. That's the top of it. When I try to push N2, which is my new node, N2 will go on top of that. And when I've exited the push function, here's what it should look like. In a moment. Yeah, you can do it. One more line. There we go. So now N2 is on top, N3 is below it, and there's a pointer from N2 to N3, which is exactly what we want. And then finally, we want to push N1 to go on top of that. And so when we do so, we need to update the top, which is going to be N1 instead of N2. We need to make sure N1 points to N2, and we need to make sure we don't lose any information in the process, which is why the order matters a lot. If you took the 3 lines of code I wrote and you change the order, sometimes it won't work. So you have to be very, very careful. And now here's what we have at the end, which is ideally what we want. N1 is on top, N2, N3. And the order we pushed them was N3 got pushed in first, N2 got pushed on top of that, and N1 got pushed on top of that. A stack. Okay, so we got our stack. Isn't that cool? Doing this is not something that is very easy if you haven't practiced with it, which is why I think you should do the exercise. Now, let's do the second exercise, starting with implementing the isEmpty function. I think that's the best place to start because that's a lot easier than the rest of this, which is implementing pop. Pop means take the top off the stack, which means you need to update what the top is after that, and you need to return the data that you've collected. Now, before doing pop, I need to make sure the stack isn't empty, so I need a function called isEmpty. Fortunately, this is also a 1 line of code. So when it's a 1 line of code, not a bad idea to just write it right away. And the 1 line of code is really simple, is the top null? If the top is null, then the stack is empty. If the top is not null, the stack has stuff in it. Pretty simple. Okay, so that's isEmpty. Now, implement pop and ensure I don't try to pop from an empty stack. If you do, really scary things can happen. Now, pop is going to return a node, so I need to make sure that's the type of it. There's no parameters, because we always take whatever the top is. And coding this is, just like push, going to take a few steps, so you got to be careful about our order in which we do everything. So, the first thing we need to do is check if it's empty. If it's empty, we just return an empty node and say there's an error or something like that. Yeah, I think I try to return null here, but then C++ complains to me because it really wants an actual node to be returned. And I don't think you actually have to write this .isEmpty. I think just doing isEmpty would work okay because isEmpty is a member of the stack class. But just for fun, you can write this if you feel comfortable. So this is an error. If you stack is empty and you try to pop, it shouldn't work. I tried to return null, but then the compiler got mad at me. I think normally returning null should be okay, but maybe Python Tutor doesn't like it in particular. I'll fix that in a bit. So let's think about how popping works. There's once again 3 steps that are going to go to it. And at the end of it, what should happen is I should be able to return the thing that was on top, and the new thing on top should be the second item. Now, if I'm going to return this, I need to hold on to it. So temporarily, I need to store what the old top is that I'm going to return. The next step is I need to reassign. So once the thing has been removed, there's a new top of the stack. It's the thing that was below it. So I need to update the new top to be the next one. Literally the next one. Whatever my thing is I'm removing, next from that should be the top. And then I just return the thing I pulled away. So my old top is going to be what was there. That's the thing I'm going to return. I'm going to take this as an object, not as a pointer. Although I guess, again, you could return what's at the pointer. But we'll make a copy of what was at the old top and return it. We need to reassign the new top to be the next thing, which is very convenient. We can just take what was the top and go to the next one. We're there. And now we just return the old top. Pretty simple. This is going to crash because it doesn't like returning null when the stack is empty. It needs to return an actual node. But to make sure that actually happens, I need to call it. So I'm going to first double check that S is empty. Well, this shouldn't really do anything unless I try to print it. So first I'll try to pop. If I try to pop, it should tell me the stack is empty and then return. So this I think I execute. Yep. And then it's going to be mad because I can't return. Oh, I forgot to use the arrows. Right. Because this is a pointer to the stack in question. So I have to use this arrow is empty anytime you're using this. And now here is where it gets mad, is it can't convert from a null to a node, so you have to return a node. Unfortunately, it got kind of angry at me for trying to bypass that. I wasn't able to just return nothing either. It was still just as mad. Yeah, it has to return a node, unfortunately. So I'm just gonna make an empty one, return that. I think I'm figuring out that I have to do exactly that. But once again, this is the kind of thing that you only really figure out through practice. Like even these mistakes that I've made are ones just because I haven't practiced stacks in a little bit, so I make some of these little clumsy errors. But okay, here we go. So we are making a stack. It starts out as empty. We try to pop. When we pop, we check to see if it is empty, and it is. So since it is empty, we cannot pop from it. And so the code is angry at us and says the stack is empty, you can't do that. Okay. So far, all is well. Yeah, that's fine. Okay, now we need to actually make sure popping is working. So when we think about what we've done, we've pushed N3, N2, N1 in that order, which means 9 is at the bottom, 8 is on top of that, and 7 is on top of that. So when I pop, I should get a node back that has the thing that was on the top, which was 7. So when I print out the data from the node that I pop off the top of my stack, it should be a 7. And not only should it be a 7, but my stack should be updated so that it starts at N2 with N3 below it, and N1 is gone. And so once I build my stack, I should have the structure we saw before, which looks just like this: N1, N2, N3. N3 is on the bottom, N2 is above it, N1's above that. When I pop, N1 should come off, and I should grab the data from that node. So when I do s.pop, before I do .data, we're going to go in. Stack is not empty, so I have to do stuff. I'm going to hold on to my copy of the node that has the 7 in it, which you see at the bottom there, old top. I have that. Now I reassign the top of my stack. So instead of being N1, it's N2. So you can see the arrow change, I guess, when I go to the next line. Yeah, there we go. So now it's pointing to N2. And I'm still holding on to my N1, the one I'm going to pop with the 7. So I'm going to return that. And when I return that, I can say this dot data, and it gives me the 7. And there's the 7 right there. And if I was to pop again, my stack is N3 at the bottom, N2 on top of it. When I pop, the N2 should come off, and I should get an 8 out of the thing that I'm grabbing. You really want to think about stacks and nodes and such kind of as physical objects, because I feel like if you do it that way, it's a lot easier to kind of picture in your head how everything is working, as opposed to being this like kind of untangible nonsense. So in the code, I just added in 2 more pops. So now we have N3, N2, N1 from the bottom to the top. When I pop, N1 comes off first, N2 comes off second, N3 comes off third. And so I should get 7, 8, 9 when I pull them in that order. And it should update the stack as we go, and then once I've popped everything, my stack just says null, because there's nothing left in the stack. How much time do we have left? Almost done? Okay, so just as a few like closing statements, I cannot emphasize enough how important it is to try this. Like, actually try to get it to work. Make your main function pop and push different things, do different combinations of stuff. It's really important that you be able to write this kind of code and try it and see what happens. It's not as important that you do it perfectly in the first try. I didn't do it perfectly on the first try, but that's not the important part. The important part is that you actually give it a shot, see if you can actually get the pieces working together, moving around the pointers and all that kind of stuff. And if you can do that, I think that's going to give you the best advantage when it comes to future tests and so on, and future in your CS career, because stacks are probably one of the most important data structures you need to know how to use. Literally, the word stack is on Python Tutor right there, because that's how your program is actually working. It uses a stack to function. So I recommend give this a shot. Don't just watch the video and talk over it like I did, but actually try programming this. Get your hands dirty, and I think that will be the best thing for you to try out. So I think that pretty much concludes my video. I'm going to pause this here because there's nothing really left to see. But I will see you in the next class/video. Take care, everybody.